Okay, this is section 5.2. This is the first video in this section, and I intend to make 2 videos for this section. We want to look at, first of all, the trigonometric functions. This is going to be one of the most important topics that we'll cover and use day in and day out for the rest of the semester. There's a couple of things that I want to walk you through just simply with drawing a picture. When you draw a picture of your triangle, which we're going to be working with triangles over and over and over again, a couple things. First of all, XY is going to be some point on your axes. So it's not necessarily, it's not going to be at the origin. It's just going to be somewhere on the coordinate axes. Your terminal side is going to be going through that point, XY, and the angle theta is going to be in standard position. Now, one thing that you just need to really hang on to is that theta, when you draw it, theta is always at the origin. Always, always, always. The distance from the point to the origin, this is going to be called our radius. That makes sense. All right, because as we rotate that initial side, it forms a circle, so that's a radius. So the distance is going to be radius, and you can notice on my picture there, we call that r. So a couple of the things that you see here is that my x value is along the x-axis, my y value is along the y-axis. But here's the big deal. The right angle cannot be at the origin. The right angle cannot be at the origin. So you'll notice here, my right angle is not at the origin. If you put your right angle at the origin, you've done it incorrectly. Theta is the angle that should be at the origin. So then if I have this picture, and for the record, this is called the reference triangle. I'm going to refer back to it. I guess that's a good thing that we called it the reference triangle. We're going to refer back to it quite frequently. So, all right. So as I look at this picture, we have 6 trigonometric functions. We've got sine, cosine, and tangent. These are the 3 basic foundational trigonometric functions. And then we also have cosecant, secant, and cotangent. I'm going to start with the 3 basics. The 3 basics being sine, cosine, and tangent. And first of all, let's look at just simply the notation. So the sine of my angle is written S-I-N, but still pronounced sine. The cosine is written C-O-S. This is the abbreviation, the notation. And tangent is T-A-N. Now, I want you to notice that the angle theta always goes with my trig function. They can never be separated. So you have to have the sine of an angle, the sine of theta, the cosine of an angle, the tangent of an angle. And sine's ratio, basically the definition for sine is that you're always going to be looking at the opposite divided by the hypotenuse. The opposite divided by the hypotenuse. Now let's go to our picture and let's talk about what that means. So this is my angle theta, and you can think of it here or you can think of it on the inside of the triangle. Both of those will work. The opposite side of my theta is going to be side y. And the hypotenuse, well, we remember that the hypotenuse is always going to be opposite the right angle. So the hypotenuse is my r. So then what I have here is that my sine of theta is going to be the y value over the r value, the opposite over the hypotenuse. All right, the cosine, notice it's going to be the adjacent side over the hypotenuse. Now this says cosine of theta, so again, let's go focus on theta. What is adjacent to theta? Well, there's actually 2 things adjacent to theta. An x is adjacent to theta, and so is an r. But the thing is r is always the hypotenuse. We're not going to ever call it an opposite or an adjacent. So since r is the hypotenuse, it automatically gets named the hypotenuse. It will not get named opposite or adjacent. So then the only adjacent side that we can have is going to be that x value. So our cosine then is going to be the x value, the adjacent side, over the hypotenuse, the radius. For tangent, this is going to be the opposite side divided by the adjacent side. So the opposite side is y, the adjacent side is x. And so my tangent of theta is going to be y over x. Now, notice that I have written above here SOHCAHTOA. SOHCAHTOA is an easy way to remember our ratios. So you have here that sine is going to be opposite over hypotenuse. That's where the O and the H come from, opposite over hypotenuse. Cosine will be adjacent over hypotenuse. Tangent will be opposite over adjacent. So SOHCAHTOA. All right. Now, when we go over to the secondary trig functions, the cosecant, secant, and the cotangent, the first thing to notice is that these three are tied back to the original three. So cosecant is the same as 1 over sine, or the reciprocal of sine. Secant is going to be the reciprocal of cosine, and cotangent will be the reciprocal of tangent. So these guys are always going to be reciprocals of each other. And you can tell that by looking at here, sine is opposite over hypotenuse, cosecant is hypotenuse over opposite. They are reciprocals of each other. Okay, same thing with cosine and secant. Same thing with tangent and cotangent. Now, the way that I write, the notation that I write these three, cosecant is abbreviated CSC. Again, it cannot be separated from its angle. Secant is abbreviated SEC, and cotangent is COT. We still call them cosecant, secant, and cotangent. Okay, so now let's use our reference rectangle, and let's find out what this is. Now, there's actually two things you can use. You can either use the reference rectangle, or you can go back to these three and just simply get the reciprocal. All right, so my cosecant then is simply going to be r over y, and you can tell that on your triangle, the hypotenuse divided by the opposites. Secant is going to be r over x. Tangent is going to be x over y. For the record, r is always going to be a positive number, at least until later in the semester, because it's a distance. All right, let's look at some examples. So example number 1 says that the terminal side of angle theta in standard position passes through the coordinate 12, 5. Find the values of all 6 trig functions. Let's talk first of all about how to draw the triangle. So the very first thing that we're going to do in our step is we've got to draw the triangle, but we need to make sure that we draw it correctly. So you'll notice that I marked the x value of 12 and the y value of 5. And remember that my right angle is never allowed to be at the origin. So my right angle, let me shift this over a little bit so that it looks like it makes sense. My right angle has to be on the x-axis, but never at the origin. On the x-axis, not at the origin. So when I draw it like this, I can tell that this guy here is 12 and this guy here is 5. My theta is the angle that's always at the origin. So that's going to be the first thing. Draw your triangle. The second thing is find the missing side. So we're going to use the Pythagorean theorem then to do this. And we'll just do the leg squared plus leg squared. So 5 squared plus 12 squared is equal to my r squared, my hypotenuse squared. So 25 plus 144 is 169. So my r is 13. So the missing side is 13. And then the third thing that we're going to do is we're just simply going to go find those trig values. So we're going to use SOHCAHTOA. All right. SOHCAHTOA first to get our sine, cosine, and tangent. So remember, sine is going to be opposite over hypotenuse. Opposite over hypotenuse. So that'll be 5 over 13. Cosine will be adjacent over hypotenuse. So it'll be 12 over 13. And then tangent is going to be opposite over adjacent. So it'll be 5 over 12. To get the second 3, I really don't even need my triangle anymore. I just need to get the reciprocal of these guys. So cosecant is going to be 13 over 5, secant 13 over 12, cotangent 12 over 5. Now if we go to example number 2, this one's a little different. Once again, I've started the picture for us. We have our angle theta is in standard position. It's going through the coordinate 8, -6. And this is a coordinate in the 4th quadrant. So then let's go ahead and draw that. And we'll connect our right angle. Sorry, that's just a little bit off there. So we know that this value is 8 and this value is -6. We do the Pythagorean theorem. And once I do the Pythagorean theorem, I'm just simply going to find that this side is 10. So I'll let you do the math on that one. All right. So then let's go ahead and find the 3 foundational trig functions. So once again, SOHCAHTOA. Sine is going to be opposite over hypotenuse. So that's going to be -6 over 10. But you and I both know that we're never going to leave fractions unreduced. So it'll be -3/5. And our cosine is going to be adjacent over hypotenuse. So that'll be 8 over 10, which will reduce to 4/5. And then tangent will be opposite over adjacent. So -6 over 8, which will reduce to -3/4. At that point, we don't need the triangle anymore. We just need our 3 original trig functions to get our secondary ones. So cosecant is going to be the reciprocal of sine, so -5/3. Secant will be 5/4, the reciprocal of cosine. Cotangent will be -4/3, the reciprocal of tangent. All right, jumping to example number 4. So this one's going to be a little different. Notice that I drew the reference triangle up here, so you might want to draw this so that you don't have to go all the way back to the first page to look at it, because we're going to need the reference triangle on this particular example. So my directions say that I should find the values of the 6 trig functions for the angle of 360 degrees. All right, now 360 degrees, we know is at the starting position. It's at that initial position, the positive x-axis. So I've marked that, and I've given it a coordinate. And folks, I could have given it the coordinate 5, 0, 30, 0, 100, 0. I could have given it anything like that, but I just went with boring this time. And I said that it's a good coordinate to just put 1, 0. But the problem here is that I can't draw a triangle. So what I need then is I need my reference triangle, okay? So my reference triangle hands me my 3 trig values, the y over r, the x over r, the y over x, opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent. All right, so that's just what we've already done. So once I use the reference triangle to get those values, then I can take those values over to the picture I've drawn. So notice that my y value is 0. My radius is 1. Now, how do I know my radius is 1? Well, if I had drawn a circle, see if it'll work for me. If I had drawn a circle, my radius would have been 1 on this circle. Okay, so I'm going to say then that my y over my r is going to be 0 over 1. Well, 0 over 1 is the same thing as 0. Well, cosine is x over r, so I'm going to use my x value over my r value. That's 1 over 1, which is 1. And then tangent is going to be y over x, so y value 0 over x value 1. 0 over 1, again, that's 0. Now, I don't need the picture anymore, and I don't even need the reference triangle anymore. But what I am going to do is when I get the reciprocal, I'm going to use these 3 values. So for cosecant, this is going to be 1 over 0, and I know that's undefined. You can't have 0 on bottom. Secant is going to be 1, and then cotangent is also going to be 1 over 0, which is undefined. All right, on part B, this one says that the angle has the terminal side passing through 0, -5. So once again, I cannot draw a triangle. So when I cannot draw a triangle, I'm going to go back and I'm going to use my reference triangle. Okay, so that's the deal with that. All right, so my reference triangle tells me that my three originals, once again, this is the exact same thing as that I did on the last question. Y over R, X over R, Y over X. So we go over here then, and we're going to take our Y value divided by our R value. So Y divided by R, -5 over 5 is a -1. For X over R, that's going to be 0 over 5, which is 0. And then for Y over X, I'll use my coordinate there. So -5 over 0, which is undefined. To get my secondary trig functions, once again, I'm going to use the unsimplified version and get the reciprocals. So for cosecant, this is going to be -1. For secant, this will be 5 over 0, which is undefined. And then for cotangent, it'll be 0 over -5, which is equal to 0. Now, what I'd like you to do next, I'd like you to pause the video, and I would like you to fill in the table that's in your notes. So this table is asking you about all 6 trig functions of your quadrantal angles. Remember, those are the ones that land on an axis. And I chose some coordinates for you, just using a 1 radius, just to make it a little easier. So pause the video, go ahead and fill that out. I'm going to uncover it, but make sure you've got it filled out first. So go ahead and pause the video. All right, now that you're back, I'll go ahead and uncover that. And the directions here in this reflection question says, which row in the table gives trig function values for an angle measuring -270? Well, remember that -270 says I'm going to go in the opposite direction. So here's a -90, keep going as a -180, here's a -270. So 90 degrees is coterminal to -270. And 1,350 is coterminal with 270. You would just need to take whole circles and keep subtracting. So 1,350 minus a whole circle, minus a whole circle, minus a whole circle. You'll probably have to do at least 4 whole circles that you'll subtract. I've already given you these identities, or just giving them to you again. And let's look at example 5 using these identities, these reciprocal identities. So if you are told that cotangent of theta is equal to 4, what is tangent of theta? Well, tangent and cotangent are reciprocals of each other. So you know that the tangent of theta is going to be equal to 1/4. Well, if you're told that cosine is -2 over the square root of 20, what is the secant? Well, we will get the reciprocal. So that'll be, notice that what I did there is I took the root 20 and I simplified it to 2 root 5. And then I did the reciprocal. So I have -2 root 5 over 2. But then, of course, I can reduce those 2's because they're both on the outside. All right, so stay tuned, and the second video will be coming up.